Good day. This presentation introduces analytical chemistry. I am your instructor, Irshad B. Banjal. I am one of the instructors in the education program under CGEMS. In this discussion, we will examine the scope of analytical chemistry, its significance, and application. Before we start, let's read our objectives muna. First one is to summarize the historical background and development of analytical chemistry. We will differentiate the branches of analytical chemistry. We'll describe each of the steps in the analytical chemistry. And in the analytical process, let's appreciate the importance of analytical chemistry as applied in other fields of study. All right, let's make this a bit interactive. So I have a question for you here. Do you know the person in the portrait? Yes or no? Who's known as the father of modern chemistry? Who knows the answer? Very good. Good try. The correct answer is Antoine Lavoisier. He is often called the father of modern chemistry. Lavoisier not only named oxygen and hydrogen, but he also helped develop the metric system, showing how chemistry connects to everyday life. We'll learn later his contributions to analytical chemistry as we move forward in this lesson. Now let's connect science with a bit of history. Gold has always fascinated people, not just in science but in history and culture too. In fact, the practice of testing gold through fire is so ancient that's even mentioned in the Bible. We can see here, Zechariah 13:9 talks about it as a way of refining and proving purity. Let's read. This third I will put into the fire. I will refine them like silver and test them like gold. They will call on my name and I will answer them. I will say they are my people and they will say the Lord is our God. The word assay means examination of an object to determine its composition. This idea of testing gold through fire wasn't just symbolic, it was practiced in real history. There's even a story where the king of Babylon complained to Pharaoh Amenophis IV that the gold he received was less than its weight after being tested in a furnace. So how did people in ancient times already understand these methods of testing metals? They have already developed the ancient techniques of colorimetric method, a way to know the purity of any substance. And color determines the identity of the substance. Gravimetric method, or knowing the composition of every mixture by way of weighing, and fire assays. Stories of testing gold don't end in Egypt and Babylon. One of the most famous comes from ancient Greece, the story of Archimedes' Eureka. I know you're familiar with that expression. Imagine this. King Hiram of Syracuse suspected that his new crown wasn't pure gold, and he challenged Archimedes to prove it. After much thought, Archimedes finally discovered the answer while bathing, realizing how water displacement could reveal the crown's true composition. That brilliant moment, his expression Eureka became one of the history's most celebrated breakthroughs. This was first recorded by the Roman architect Vitruvius in the first century BC. From ancient tales of gold testing to Archimedes' brilliant discovery, the search for truth in materials kept evolving. Fast forward many centuries, we arrive at the 18th century when analytical chemistry truly began to take shape through groundbreaking work of the father of modern chemistry, Antoine Laurent Lavoisier, and of course other pioneers. He was the first one to use an analytical balance. This is one of the weighing scales that can measure up to several places of decimal to accurately measure the mass of any substance. He also named two elements in the periodic table, and that's why he is called the father of modern chemistry. In the 19th century, the discipline was further developed by these two great minds, and they are the founders of analytical chemistry. We have Carl Remigius Fresenius and Carl Friedrich Mohr. Carl Remigius Fresenius, he is a German chemist who is considered to be one of the founders of modern analytical chemistry. He wrote the first book of analytical chemistry. He also wrote the first analytical chemistry journal. He built a laboratory at his house that opened in 1848, and that laboratory trained students in gravimetric techniques that he himself had developed through time. So many of the methods that Berzelius developed are still fundamental in modern laboratory practices. On the other hand, Carl Friedrich Mohr, he is a German chemist who's best known for the titration method. Um, Maybe in the future we will have this one we will have one laboratory activity for titration. He devised a colorimetric endpoint for silver titrations, and he invented a lot of laboratory tools, glassware, tools like pinchcock, the cork borer, Morse balance, pinch clamp, the pinch clamp burette, and the volumetric pipette. His 1855 book on titrimetry, Handbuch der chemischen Analyse, became the standard reference for analytical chemists for many, many years. So that's all for the brief historical background of analytical chemistry. Let's learn more about the subject, analytical chemistry. So, what is analytical chemistry? Analytical chemistry is the study of chemical analysis through analytical instruments. It can be used to identify, measure, quantify, and different substances in a sample. So, generally, the purpose of analytical chemistry is to identify the components of a sample, also to quantify in terms of numerical value the components of a sample, to determine the structure of a sample, to study the kinetics of chemical reactions, and study the thermodynamics of chemical reactions. In our subject, we will at least do the first two purposes to identify the components and to quantify the components in a given sample. I hope we can do that in this term. Analytical chemistry is divided into two branches. One is qualitative analysis, and the other discipline is quantitative analysis. Qualitative analysis is a method that deals with the determination of the quality of a particular compound irrespective of its quantity or concentration. So when we say qualitative, this is more about descriptive. It only measures the quality in terms of descriptive quality of a material. It determines the identity of a constituent species of a substance. It does not, however, measure the amount of a substance. On the other hand, quantitative analysis is a method of determining the absolute or relative quantity regarding the concentration of one or more substances present in a sample or a compound. There are two methods for quantitative analysis. One is gravimetric analysis and the other is volumetric analysis. Gravimetric analysis is measuring by weighing the sample. Volumetric analysis, on the other hand, is determining the quantity of a sample by means of its volume. To differentiate the two, in terms of measurement, gravimetric analysis, it only measures the mass of a substance. Volumetric analysis, it measures the volume. In terms of approach, the analyte, the one that is being described and measured, is isolated and weighed. In volumetric analysis, the analyte reacts with a known reagent to form a solution of known concentration. So in other words, volumetric analysis is more about chemical reactions. In terms of advantage, gravimetric analysis has very high accuracy since mass can be measured precisely using the appropriate tools in the lab. Volumetric analysis also has a high accuracy, but it is dependent on careful measurement and correct indicators. For the disadvantages, gravimetric analysis is usually slow and laboratory intensive, whereas a volumetric analysis is generally fast and convenient because it only depends on chemical reactions. Examples of gravimetric analysis is the determination of amount of water in a sample by way of measuring its mass. Volumetric analysis example is determination of acidity of a solution. So in other words, to generalize, gravimetric means mass-based, slower, and more precise. Volumetric is volume-based, faster, and widely used in practice. If we're going to perform any laboratory activity in analytical laboratory, if we're going to perform any laboratory activity in the analytical chemistry, we will follow the general analytic process or general analytical process. These are a series of steps which analytical chemists take when performing qualitative and quantitative analysis. Analytical chemists should be involved in every step. Just remember that. You are the analyst in this you are the analyst in this case. You really have to be the problem solver, which is a critical part of the team and of the community deciding what, why, and how. So what are the steps of the analytical process? The first one is defining the problem. In defining the problem, we state clearly what needs to be determined. For example, the amount of chloride in water. Let's say we want to measure that. The next one is selecting a method. You have to choose the most suitable analytical technique. For example, if it requires measuring the mass, then that's gravimetric. If it requires measuring the volume, then that's volumetric. Or maybe through the use of other methods, for example, instrumental and many other methods. The third step is obtaining a sample. This is when we collect a representative portion of the materials to be analyzed. Remember that not all the sample will be analyzed. We only take a portion or a part of the sample, and that's enough to have a general idea about the sample. Then the fifth step is the fourth step, is preparing the sample for analysis. There are many processes actually. We make sure that the sample is ready for the actual analysis. For example, we might dissolve the substance first, or grind them first, or undergo a series of mechanical separations. The fifth step is performing any necessary chemical separation. In this step, we remove interfering substances if needed. The sixth step is performing the measurement. This is to carry out the chosen analysis in the second, third, fourth, and fifth method. Actually, it's on the second method. In this step, we will carry out the chosen analysis by weighing, by titration, spectroscopy, and many other methods. Lastly, we will calculate the results and report it. We'll process the data, express the results clearly, and present the findings. There are many terms used in analytical chemistry. The widely used terms are the terms analyze and determine. Did you know that these two terms have different meanings? The terms analyze and determine are two different words. What do you think is the main difference between analyze and determine? See daw? Okay, very good. Analyze is to inspect, to know the constituents or components. So we say a sample is analyzed for all of its constituents. When you want to inspect and to know the specific component of a sample. The thing that we measure is, or the substance that we measure is the analyte. An analysis may be partial if we only want to determine its component partially, or full. Now, for in this case, that is complete analysis. On the other hand, the word determine is to measure the analyte. Hence, when we say, in analyzing food for its chloride content, we determine the chloride concentration. We want to know the composition of food, and that's why we measure the chloride concentration. We want to know we want to analyze the food for its chloride concentration. We want to know its component in terms of chloride concentration, and that's why we measure it. There are many things related to determination and analysis of constituents. Constituents are parts or ingredients of a sample. If that constituent is more than 1% of the sample, then that's a major constituent. If that constituent is 0.1 to 1%, and that's minor constituent. Trace constituents have a percentage of less than 0.1% of the sample. If it's a few parts per billion, then that's ultra trace. Most importantly, when we discuss the methods used in analytical chemistry, most of the time quantitative analysis is used more than qualitative analysis, though they go both hand in hand. But most of the time, analysts take the side of the quantitative method. Quantitative methods are used to determine the identity and the quantity of the analytes in the field of analytical chemistry, and that can be broadly divided into classical or instrumental method. Let's learn about classical methods of analysis. If we say classical methods of analysis, that's a method for checking for the presence or absence of particular compound in a given analyte using traditional lab tools. I know most of the time, or most of these tests, you have already done this in the laboratory. Example, acid test for gold. This is one of the tests for purity of gold. Castle-Meyer test. This employs phenolphthalein, a kind of indicator, to check the presence of hemoglobin in a given analyte, especially when blood is involved. Flame test. It is used to check for the presence of specific elements in an analyte by exposing it to a flame and observing the change in the color of the flame, because every element has a unique pattern and coloration. Gravimetric analysis. This is used to determine the amount of water in a hydrate by heating it and calculating the weight of the water loss. And volumetric analysis, also known as titration, is a kind of analysis where a reactant is added to the analyte till an equivalence point is obtained. The other part of quantitative analysis is through instrumental methods. These are methods to analyze substances using machines and advanced tools. So most of the time, if we cannot perform this, that is because we lack the tools required for this. Example, spectroscopy. This involves the spectroscope. It measures the interaction between electromagnetic radiation, example light, and the atoms or molecules belonging to a sample. Next one is electrochemical analysis. This is where the analyte is placed in an electrochemical cell and the voltage or the current flowing through it is measured. Then lastly, calorimetry. The analyte is measured in terms of its energy in the form of heat. A calorimeter is an instrument that is used to measure the heat of a chemical reaction. So we are on the last part of our topic for today. The question is, what's the importance of analytical chemistry? Analytical chemistry is the branch which is taught in almost all schools and colleges, including yours, of course. But the applications of it are made in pharmaceutical industries, food factories, chemical industries, and agricultural industries in scientific laboratories. The tools used for this purpose are quite expensive, and that's why most of the time we cannot just easily perform them in our residences. One cannot afford at home. Okay, in the field of medicine and health, analytical chemistry ensures accurate drug formulation, diagnosis, for example, when it involves blood tests, and safety of pharmaceuticals. In the food industry, tests for nutrients, additives, and contaminants to guarantee food safety and quality. In environment, analytical chemistry is used to monitor pollutants in air, water, and soil for sustainable living. In industry and manufacturing, it controls raw material quality and product consistency. In forensics, analytical chemistry identifies substances in crime investigations. And lastly, in research and education, analytical chemistry provides tools for discovering new compounds and understanding matter. So, analytical chemistry is essential for quality, safety, and progress in almost every field of study. In your piece of paper, I want you to write an essay to be submitted next week. How do you apply qualitative and quantitative analysis in your chosen degree? Cite specific examples, minimum of one paragraph with 5 sentences. Please write it legibly, observe margins, and do not use AI tools to write your assignment. Okay, that's all for today. Thank you for listening.